All right, so we've graphed sine. Now we're going to get into graphing cosine. And we're going to start this the same exact way. If you remember, sine is your y value, cosine is your x value. So instead of working with our y values, we're going to work with our x values now. Okay? So let's start with 0. Well, my x value at 0 is 1, so the value of cosine at 0 is 1. As a decimal, that's 1, and the coordinate is a and b, so that's 0, 1. Okay, we go to pi 6. The x value there is the square root of 3 over 2. As a decimal, that's 0.9. It's like 0.86 actually, but we can just round up to 0.9. And that coordinate will be pi over 6, square root of 3 over 2. We go to pi over 4. The x value there is the square root of 2 over 2. As a decimal, that's about 0.7. And the point there is pi over 4, square root of 2 over 2. Go to square root of 3 over 2. Or no, sorry. Go to pi over 3. Now the x value there is 1/2. So the value of cosine there is 1/2. As a decimal, that's 0.5. And the coordinate is pi over 3, 1/2. Then if we go to pi over 2, the value of cosine there is 0, because x value is 0. As a decimal, 0 is 0. And then our point is pi over 2, 0. Okay, I'm not going to go through this whole circle because it's a waste of time. And you guys can do this on your own. You don't need me to hold your hand through it all. So continue to fill out the rest of this chart using that circle. Okay, pause the video, fill that out, and then come back in a second. So once you've done that, if you notice here, we start at a high point. 1 is the highest point we go to, and this is decreasing all the way down to -1. And then we start getting bigger. So from here to here, we're increasing back to our high point. Okay, that tells us a lot about what this graph is going to look like. So we're going to start at a high point, go clear down to a low point, and then come back to a high point. Okay, that will make more sense once we get graphing this, but I just want you to realize that you always start at a high point on cosine, go to your lowest point, and then come back to your highest point. Okay? So let's get into graphing this. So let's graph the points in column D. So the first one is 0, 1, which is right there. And I labeled this axis the same way I labeled the sine axis. So if you need to label that, pause the video and label it, but it's labeled the same way I did it in the sine one. Okay? Pi over 6 is 3 pi over 2, or square root of 3 over 2. It's about 0.9. So that's that point right there. At pi over 4 is the square root of 2 over 2, which is about 0.7. Pi over 3, it's 1/2. Pi over 2 is 0. 2 pi over 3 is -1/2. 3 pi over 4 is negative square root of 2 over 2, which is negative 0.7. 5 pi over 6 is negative square root of 3 over 2, so about negative 0.9. Pi is -1. That's my low point. Notice it's right in the middle of our whole graph, the low point is. And then 7 pi over 6, that's negative square root of 3 over 2. 5 pi over 4 is negative square root of 2 over 2. 4 pi over 3 is negative 1/2. 3 pi over 2 is 0. And then 5 pi over 3 is 1/2. 7 pi over 4 is about 0.7 or square root of 2 over 2. 11 pi over 6 is the square root of 3 over 2. And then 2 pi is 1. Okay, and then we have our little graph here. And this graph makes a C shape. Cosine makes a C shape. It also kind of looks like ovaries. So whichever way you want to remember it, I don't care. But just remember, sine makes an S shape, cosine makes a C shape, or it makes the graph that looks like ovaries. Okay? This is all the same as it was for sine. So the amplitude is A, the period is 2 pi over B, the horizontal shift is C, vertical shift is D, frequency is b over 2 pi, and the midline is y equals d. So it's all the same as sine. We didn't change anything. The graph just looks different. We start at different points. Okay, but you find the amplitude, period, everything the same way. Okay, so we need to evaluate these functions, and we need to find the exact form. And the way we're going to do this, you can just use your chart, you can use the graph, or you can use the unit circle. Okay, so 5 pi over 3, let's find that. That's that point right there. That goes up to 0.5. So g of 5 pi over 3, or cosine of 5 pi over 3, is 1/2. Now 11 pi over 6, that's the square root of 3 over 2. 5 pi over 4, that goes down to about negative 0.7, which is the same thing as negative square root of 2 over 2. So that's what that is. 2 pi over 3, negative 1/2. Pi fourths, square root of 2 over 2. And then pi is negative 1. Okay. Now let's get into actually graphing these. So always start by first labeling your A and your B values. So A is 3/2, B is 4. So the amplitude is 3/2, which is about 1.5 if you want the decimal. And the period is 2 pi over B, which is 2 pi over 4, which is pi over 2. Okay, for cosine, you start high and you end high. That's what I want you to remember. Start high, end high. So you start, instead of starting at the at the origin like we did on sine, we start at the amplitude. So my amplitude is 1.5. So I'm going to go up to 1.5, draw a point right there. And then my end point is also at the amplitude, and it's where the period ends. So my period is pi halves, so I'm going to go to pi halves, go up to 1.5, and that's my other point. Okay, now to get the middle point, you go halfway between, which will be pi fourths, and instead of going up 1.5, I'm going to go down 1.5. So I'm going to go to negative 1.5 and draw a point right there. Okay, and then this pattern just continues throughout the rest of the graph. So I can draw a point at pi, halfway between, go down to negative 1.5. Go to 3 pi over 2, draw a point at 1.5. At 5 pi over 4, go down to negative 1.5. Go to 2 pi, draw a point at 1.5. 7 pi over 4, draw a point at negative 1.5. And then just draw that graph. Okay, cosine, start high, end high. Let's do this one. I want you to rewrite that every time. So y equals 3 cosine of theta over 3 is the same thing as 3 cosine of 1/3 theta. I want you to rewrite that every single time you graph. Okay? So my A value is 3, my B is 1/3. So my amplitude is 3. My period is 2 pi divided by 1/3. So I'm just going to rewrite that to make it look a little bit easier. So 2 pi divided by 1/3. When you divide by a fraction, that's the same thing as flipping the second fraction and multiplying. So that's 2 pi times 3 over 1, which is 6 pi. Okay. Start high, end high. So we're going to start at the amplitude. I'm going to start at 3. End high, so I'm going to go to the end of my period, 6 pi, go up to 3. Start high, end high. Then we're going to go to the middle, which is 3 pi. That's my low point, so instead of going up to 3, I go down to negative 3. Right there, and then we can just draw that graph, and there you go. Okay? We're going to save the next two examples for class. So we have to find the midline and frequency of each function. Every time you do this, label your A, B, C, and D. So A is 5, B is 2, C is 1, D is negative 3. The midline is y equals D, so y equals negative 3. The frequency is B over 2 pi. Well, B equals 2, so that's 2 over 2 pi, which is the same thing as 1 over pi. Okay, for example B, let's label A, B, C, and D. So A is 1, B is 1/2, there isn't a C, and D is 2. So So my midline is y equals d, which is y equals 2. And my frequency is b over 2 pi, which is 1/2 over 2 pi. We're going to rewrite that to make it easier. So that's 1/2 divided by 2 pi. That's the same thing as flipping that second one and multiplying. And you can always write this over 1. Okay, that's what I did. And then flip it and multiply it. So that's 1/2 times 1 over 2 pi, which is 1 over 4 pi. So the frequency is 1 over 4 pi. Okay? Example 4. So we need to write an equation given this. So we need to write a periodic function to model a sine function that has no horizontal shift, whose frequency is 3 over 2 pi, and the function raises 3 units above its midline, and the midline is y equals -1. Kind of a lot of information, but let's just break this down. So first we know it's a sine function because it says it's going to be a model of a sine function. So we're just going to have y equals sine of theta. There is no horizontal shift. Remember, the horizontal shift is your c, so that means that c equals 0. The frequency is 3 over 2 pi. Well, the frequency usually is b over 2 pi, so that means that b equals 3. Okay, the function rises 3 units above the midline. That means that my a is 3. Because remember, the amplitude is how far it rises above the midline, rises or goes below the midline. So the amplitude is 3. The midline is y equals -1, which means d equals -1. And from that, we can graph our we can write the equation for our function. So if we use the y equals a sine of b theta minus c plus d, plug those all in, so that's y equals 3 sine of 3 theta minus 0 plus -1. Just simplify it down a little further, that's 3 sine of 3 theta minus 1. Okay? We're going to save example 5 for class. And then let's go through this. So periodic functions are often used to model repetitive motion such as springs oscillating. So if you had like a weight at the end of a spring and you pulled it down and that would kind of oscillate and stretch repeatedly, like a bungee jumper's rope, that's what it says. Each of these functions model that motion where the spring is of a different spring, but t is the measurement in seconds. And we want to find the frequency, or how many oscillations per second of each spring. So how many times this thing is going up and down. Okay, and the way you do that, we're just going to find the frequency. That's b over 2 pi. Let's label our b in this function. Our b is 6 pi. So the frequency is going to be 6 pi over 2 pi, which is 3. Okay, and this, so that's 3 oscillations per second. Make sure you write that. So that's 3, it goes up and down 3 times per second. Now on this one, b equals 3 over 2, 3 halves pi. So the frequency is going to be 3 halves pi over 2 pi. Well, those pi's cancel each other out, so that's 3 halves divided by 2. I'm going to rewrite that, so that's 3 halves divided by 2. Put that 2 over 1, flip it and multiply, so that's 3 halves times 1/2, which is 3/4. So that's 3/4 oscillations per second. Okay? We're going to save example 7 for class. Remember to take the quiz. Come ready to work tomorrow, please, and I will see you guys then.